exercise 3.7 of section 3.2 brackets. So here you can see the first couple of launch of Mars shuttle and the initial mass which is 2 multiplied per 6 kg, and that after 2 minutes the final mass which is 1 multiplied per 6 kg. There is a decrease in mass. Okay, make sure. So we have the exhaust speed which is 3000 meter per second and initial velocity which is 0 itself. So now what we have to find? We have to find the shuttle speed, okay, and we have to find the thrust during same period, and we have to compare the initial total weight, okay. So you can see first we have to let the ideal rocket equation, and this we have studied already in rockets lecture, okay, and this is the exhaust speed, and we take log of initial mass with final mass, okay. Now you have to put the values. After putting values you will get the result, okay. Now further you can see there is a change in velocity, okay, which is equals to 79.3 meter per second, okay. So further you can see we have to find thrust, which is actually a force, and it is equals to the change in mass with time with the exhaust speed, okay. There's a change in mass and multiply the exhaust speed, or we can say there is a rate of change of mass, okay. Now arrange the mass which is the initial mass minus final mass with the exhaust speed, and now I have to put the values. After putting values 3000 meter per second with the exhaust speed value, and there's a time which is 120 seconds, okay. Now after putting values you will get these result, okay. This is the multiplication of exhaust speed and this rate of change of mass terms. Further you can see what we will get, okay. You can see the force which is 25 mega newton, okay. Now the third, where we have to compare the thrust with initial weight. So you can see the formula for weight is equal to mass multiply gravity, okay. And now you have to put the values. After putting values you will get the weight which is 19.6 mega newton. So this is all about from my side for comparing the initial weight. Okay, thank you.